Our vision of space and time, as we conceive it in everyday life, is very far from the reality that physics has revealed to us over the centuries. In general, we consider space as the place that contains objects, a container in which we can move. For us, time is seen as a continuous flow, the succession of events that follow a chronological order, the day-night cycle, the alternation of seasons, birth and death. These are familiar and seemingly simple concepts on which most of us agree. However, this view of space and time as separate and immutable entities is the result of our sensory perception of reality. No one would ever imagine that space and time could change or even merge. Yet, in the history of science, these concepts have been at the center of numerous philosophical and scientific debates until the surprising conclusion emerged that space and time are not two separate entities but form a single reality, space-time. This leads to a fundamental question: what are space and time really? Is it possible that time flows the same way for everyone? If we measure space in meters and time in seconds, how is it possible that the two can merge? How can two seemingly distinct concepts become part of a single four-dimensional entity? One of the first definitions of space and time in relation to physical phenomena came from Aristotle, who, in 350 BC, treated them as closely related concepts. Aristotle associated time with change. Without movement, time would have no meaning. Space, on the other hand, was seen as the place that contained material bodies, like a vase that holds water. However, as the centuries passed, philosophical thought evolved, and definitions of space and time shifted from purely philosophical interpretations to scientific explanations, especially thanks to developments in the field of physics. Long before Einstein, however, another great scientist, Galileo Galilei, laid the foundations for the theory of relativity. His Galilean relativity, formulated in the 17th century, indicated that the motion of an object is relative to the chosen reference system. For example, if we are in a car moving at a constant speed, we will see a pedestrian on the road moving backward. But for the pedestrian, it is the car that moves forward. This concept of relativity shows us how we perceive movement in relation to our point of observation. In Galilean relativity, speeds and distances are relative to the observer. If we were to throw a ball from a moving car, for someone inside the car, the ball would move at its own speed, but for someone observing from the outside, the ball's speed would be greater because the speed of the car is added to it. However, for Galileo, time flowed simultaneously and absolutely for everyone, and space was also absolute and unaffected by motion. In the 18th century, Newton's vision of space and time as absolute entities became the predominant theory. Newton imagined space as an immutable entity, a container in which events took place, regardless of the presence of objects within it. Time, for Newton, was a continuous flow that passed at the same rate for everyone, unchanged and uniform, regardless of circumstances. His view of space and time, which was separate from physical events, remained the norm for over 2 centuries until Einstein arrived with his theory of relativity. In 1905, with the publication of Special Relativity, Einstein completely overturned the traditional conception of space and time. With special relativity, the separation between the 3 dimensions of space and time disappeared, and the 2 concepts were unified into a single entity, space-time. Einstein demonstrated that our movement in space is not independent of our movement in time, but that both are interconnected. The measurement of time and space depends on the observer and their speed. If 2 people are in relative motion to each other, time will pass more slowly for the one in motion compared to the one at rest. This phenomenon, which has been confirmed by experiments, implies the absence of absolute time. Each observer has a personal view of reality, depending on their state of motion. In 1908, the German mathematician Hermann Minkowski, a collaborator of Einstein, presented a geometric vision of special relativity, treating spacetime as a single 4-dimensional entity. According to Minkowski, the position of an object in space is not defined by just 3 spatial coordinates but by 4 coordinates, 3 spatial and 1 temporal. This geometric meaning of the universe leads us to understand that the faster we move through space, the slower we perceive the passage of time. Minkowski's relativity establishes that space and time are not separate but interact with and influence each other. Imagine traveling a distance from point A to point B in a car. The distance traveled in space would be the sum of the lengths of segments x, y, and z, which represent the spatial coordinates. But in space-time, not only does space contribute to the distance traveled, but so does time. In fact, The faster we move through space, the slower we move through time, and vice versa. The speed at which we move through space reduces the amount of time we perceive. So, at high speeds, time appears to slow down, and space seems to contract. If we then consider the speed of light, which is the maximum possible speed in the universe, we discover that it represents a fundamental limit. The speed of light is about 300,000 kilometers per second, and it is the constant that unites space and time into a single measurement system. The speed of light allows the transformation of time into space and vice versa, giving rise to the concept of unified space-time. With general relativity, Einstein expanded this theory by introducing gravity as a fundamental aspect of the concept of space-time. Gravity, according to general relativity, is not a force as previously thought but a curvature of space-time caused by the mass of an object. Massive objects like planets, stars, and galaxies distort the space-time around them, creating what we call gravity. Einstein and Minkowski's vision of space-time revolutionized our understanding of the universe and forever changed our way of seeing reality. This evolution of thought has transformed seemingly simple concepts, such as space and time, into interconnected entities that not only determine our perception of the world but also the behavior of physical laws on a cosmic scale. Thank you for watching. Leave a like and subscribe to the channel so you don't miss the next videos.